Hi everybody. So today we're going to be talking about division properties of exponents. So yesterday we did mostly multiplication, properties, power of a power, and power of a product. Today it's going to be very similar rules, but we're just using division. So we're going to start off by the same type of example like we did before, except for in this case when you expand 3 to the 5th power and expand 3 to the 3rd power, you'll see a lot of your stuff cancels, and when you come up with your final answer, this 3 squared, that exponent 2, you can find that that comes from the difference between the exponents of the original quotient. So, once again, your solution, 3 to the 5th power divided by 3 to the 3rd power, so we have like bases. Your solution you can get by just subtracting your exponents. So, let's move on to a few a very formal way of writing this, so using algebra instead of an example. So once again, if you have two exponential terms with like bases and the quotient, so the division of those two things, what you can do is subtract those exponents. So I can zoom in on that for you to copy it down real quick. You can pause the video. And then we're going to move on to an application of that. So let's get to it. And these should move pretty quickly, right? So if we have 2 to the 7th over 2 squared, we could subtract our exponents and get 2 to the 5th power. Same thing with part B. X to the 4th divided by x to the 3rd. I should get x to the 1st power by subtracting those exponents, right? Part C, though, we have some simplifying we have to do first. Remember from yesterday, if you have two things in the parentheses, so a product in the parentheses, you need to distribute that exponent. So that's called power of a product. When we do that, I'm left with d to the 4th, e to the 3rd over, that should be a d squared, e squared. Now, what I can do is subtract my exponents. D to the 4th over d squared should give me 4 minus 2 is 2. And e cubed over e squared, well, 3 minus 2 is 1, so I'd get e to the 1st. And then, last but not least, here, we're going to do some subtraction. So 3 to the 1 minus 2 is negative 1. 4 to the 3 minus 4 gives me 4 to the negative 1st power, and then here, I have to subtract my exponents to get 5 squared. Now what we're going to have to do is 3 and 4 have some negative attitudes. They got to go to the basement. They got to flip, right? So they're going to go to the basement to change their attitude. Right? So instead, that 5 already had a positive attitude. It's going to stay where it's at. And then the 3 becomes positive, and so does the 4. Once it changes its attitude by going to the basement, right? So, once again, you have to subtract your exponents. Another way to think about this, though, is where are my leftover 3's? If I have 1 on top, doesn't that mean I would have 1 left on the bottom, right? If I took 3 4's off the top and the bottom, that would mean I had 1 leftover 4 on the bottom. And then same thing here. If I took 3 5's off the top and the bottom, I would have the 2 leftover on the top. So that's just another way of thinking about those questions. So that way you're not having to subtract, get your negatives, do the flipping, and all that jazz. Okay? So, moving forward, these are kind of like the same questions. So I'm going to move on to our next property. This is called power of a quotient. So just like we did yesterday, when you have two items in the parentheses and an exponent on the outside, we have to distribute that. In this case, it's just a quotient. The only real difference is that you have division on the inside instead of multiplication, right? So let's formalize that a little bit. So this is called the positive power of a quotient property. We're going to do also a negative power of a quotient property, but we'll talk about that in just a second. So once again, if you have a quotient in the parentheses and you have an exponent on the outside, what this is basically saying is distribute that exponent. Once again, what that's really saying is you distribute the exponent. Another property you might want to write down, so this is the first one, what if we had a over b to the negative nth power? Right? If you were to follow this same rule and distribute the exponent, you would get a to the negative n over b to the negative n. But then b has a bad attitude, so that has to go upstairs to get some sunshine, change its attitude. A has some bad attitude upstairs, it's got to go downstairs to change its attitude. So then you're left with b to the n over a to the n. So your real property here, if you have a over b to the negative nth power, what that really does is it just flips what's on the inside and makes that exponent positive. And then you can distribute that exponent. So once again, if you have a negative exponent, what you can do is just flip whatever's in the parentheses and then distribute your exponent like you just did before. So let's do some practicing of this stuff. These first few examples should be pretty quick ones. So we just have a 4 and a 7 in the parentheses, so I only have to distribute that 2 in 2 places. 4 squared over 7 squared gives me 16 over 49. Right? This second problem, it looks like we have a lot of distributing to do. I always work my way from the inside out. So if I have a 2x cubed on the top, and I have to distribute that 3 on the bottom, I personally would recommend simplify the parentheses first. And the reason I do that is we're going to get some really big numbers if we don't do that. If we were to simplify what's on the inside first, do you see how we have an x cubed on the top and an x cubed on the bottom? Well, those are just going to cancel, and then we're just left with 2 over y cubed squared. Once I get to this point, I only have to distribute that 2 to 2 different terms, so I'm going to get 2 squared over y to the, when you have a double exponent, you have to multiply to get 6th power. So my final answer here should be 4 over y to the 6th power. Right? We could keep going with some more of these examples. I could distribute the 5 here, but I have 4 terms, so I'm going to get a to the 5th, b to the, remember a double exponent, you got to multiply those suckers. So b to the 20th, then I'd get c to the 10th and d to the 15th. I can't combine any of these because they don't have the same base, so I'm done. Similarly, if we look at this question, I have to distribute my exponents. I look in the parentheses, there's nothing I can simplify because I don't have any like bases. But when I distribute this 4, I need to distribute it not only to the d squared, but also to that 3, and then to the e and the f down in the basement. So I'm going to get 3 to the 4th power, d to the 2 times 4 is 8, e to the 4th, f to the 4th. And if you simplify 3 to the 4th, you would get 81. I don't see any parentheses, I don't see any like bases, I can't reduce my fraction, I don't have any negative exponents, so we're good to go. Let's skip this middle one here. And then this last question, like I said, I would strongly suggest reducing your fraction first. When you do that, if I took 2 a's off the top and the bottom, I would be left with 1 a on the top, right? If I were to take 1 b off of each of these, I'd be left with an extra b on the bottom. So really, all I have is a over b to the 3rd power. I distribute the 3 and get a cubed over b cubed. All right, moving on. We just talked about negative power of a quotient property. We wrote this down before, so I'll highlight it again for you. This is just when you have a negative on the outside of the parentheses, you have to flip it, then distribute your exponent. So let's practice that once or twice. Once again, when you have a negative exponent, in order to make that exponent positive, what you can do is flip your fraction, and then you can distribute a positive exponent, right? If you have a negative exponent here, that means both of these guys have a negative attitude. Both of them have to move. Then when I distribute my exponent, I should get 4 cubed over 3 cubed, and then you can simplify that to get 64 over 27. Similarly, if we had 2/3 to the negative second power, that would become 3/2 to the second power. Here, reduce your fraction to get 3, right? 3m over n. In order to make this exponent positive, I have to flip my fraction. And then what I can do is distribute my exponents. I should get 3 squared is 9 over 2 squared is 4. Distribute my exponent, n cubed over 3 cubed, which is 27, m cubed. Right? Only other thing I can do is reduce my fraction now. 9 goes into 9 once, 9 goes into 27 3 times, so I'm left with n cubed over 4 times 3 is 12m cubed. A lot of steps, right? So once again, I got to take care of my negative exponents, reduce my fractions, and then combine my like bases and do lots of reducing, right? Yeah. So let's move on. I want to repeat again, this is the same thing that we saw in section 6.2, so you don't need to write this down again, but these are good things, just like a checklist to keep in the back of your head to know if you're done simplifying or not. You can freeze this if you want, write it down again, but once again, that should be in your 6.2 notes. The last thing I want to do is talk about these scientific notation problems with division. If you recall from 6.2, and I posted some Khan Academy videos too if you weren't still sure how to do this, but if we're talking about scientific notation, that means that we have two things. Sorry, here we go. Let's say we have 2 times 10 to the 4th power divided by 2 times 10 to the 7th power. I'm sorry, let's do a 3 here. We can write this 2 different ways, right? You can use the division sign, or you might see the same expression, so these are the same thing. You might see it written as a fraction. Either way, you're going to end up with the same type of thing. I personally like to write mine this way because I can divide the constants. And now that I know that this is division, I can subtract the exponents. So 2 divided by 3 is 2/3, or 0.67, or 0.6 repeated. And then if you do 4 minus 7 for subtracting your exponents, you get -3. So a lot of you may think my final answer is 0.6 repeated, or I'm going to use 0.67 times 10 to the -3rd power. But remember, this number right here has to be between 1 and 10. So it can't be 10. It has to be a single-digit number, right? So in order to do that, I have to move my decimal to the right one place. I made this number bigger to get to 6.7. And if I make my constant bigger, that means I need to make my exponential expression smaller. So what's smaller than 10 to the -3rd? That would be 10 to the -4th. It would become more negative. So my final answer would be 6.7 times 10 to the -4th. So once again, your steps begin with divide the constants, subtract the exponents. And once you get there, you just need to check to make sure that your constant is between 1 and 10. If it's not, you need to change that decimal place and then therefore change the exponent. All right, good luck with your homework.